Have you ever pondered about your existence in the grand universe and the rules that govern it? Welcome to our journey through the fascinating yet mysterious world of quantum mechanics, a realm where reality as we know it twists and turns in ways we can hardly imagine. Quantum mechanics, a significant branch of physics, unravels the enigmatic dance of the smallest particles in our universe, the atoms, the molecules, and those elusive subatomic particles. This isn't your everyday physics. Oh no. This is the physics of the incredibly small, the unimaginably intricate. It's the field that delves into the very fabric of reality, peeling back the layers to reveal a universe teeming with possibilities. Quantum mechanics paints a picture of reality that challenges our everyday intuitions. It presents us with principles that seem to be plucked straight from a science fiction novel. One such principle is superposition, the idea that a particle can be in multiple places at once. Yes, you heard that right. It's as if you could be at home, at work, and at the beach all at the same time. Intriguing, isn't it? Then there's entanglement, another mind-bending concept. Imagine two particles light years apart, yet behaving as if they're intimately connected, their states mirroring each other instantaneously. This is what Einstein famously referred to as spooky action at a distance. These principles, as bizarre as they may sound, are fundamental aspects of quantum mechanics. They are well-tested, well-verified elements of our best scientific understanding of the world, and they have profound implications for our understanding of reality and our place within it. So, my dear listener, we're about to embark on a journey, a voyage into the very heart of existence. We'll be delving into the strange, sometimes counterintuitive, but always fascinating universe of quantum mechanics. So buckle up as we delve deeper into the quantum world and its implications on our existence. And in the quantum world, certainty is a luxury. When we delve into the realm of the minuscule, the laws of physics as we know them begin to warp and wane, giving rise to new laws that govern the quantum realm. One such law is Heisenberg's uncertainty principle, a cornerstone of quantum theory. Named after Werner Heisenberg, a German physicist, this principle proposes a rather radical idea. It is impossible to measure both the position and momentum of a particle with absolute precision. The more precisely we know one of these values, the less precisely we know the other. This isn't due to a lack of sophisticated equipment or methodology, but a fundamental attribute of the quantum world. Imagine you're trying to locate a friend in a crowd. The more precisely you know where they are, the less you know about their momentum, how fast and in what direction they're moving. Conversely, if you know their speed and direction, their exact location becomes uncertain to you. This is the essence of Heisenberg's uncertainty principle, albeit on a much larger scale. This principle challenges our conventional understanding of reality. In our everyday world, we're used to certainty. We expect to know where an object is and how fast it's moving. But in the quantum world, particles exist in a haze of uncertainty, their properties only becoming defined when observed. So how does this influence our perception of existence? Well, it tells us that at the quantum level, existence is less about concrete realities and more about probabilities. Particles don't have definitive positions or velocities until we measure them. Before measurement, they exist in a superposition of states, a blend of all possible outcomes. This fundamental uncertainty may feel unsettling, but it's also incredibly liberating. It opens up a universe of possibilities, literally. Every particle, every atom, every molecule that makes us and the world around us exists in a state of flux, constantly changing and evolving, defined by possibilities rather than certainties. In quantum mechanics, our reality is merely an array of possibilities. Imagine being in two places at once. Sounds impossible, right? Not in the quantum world. Welcome to the fascinating realm of quantum mechanics, where the ordinary rules of reality take a back seat. Here we introduce you to a concept that defies our everyday understanding of existence: quantum superposition. Quantum superposition is the mind-bending principle that allows particles to exist in multiple states at the same time. That's right, the same particle can be in two places, or more simultaneously. It's as if you could be both sitting at home and walking in the park all at once. Sounds bizarre, doesn't it? But there's a catch. This peculiar phenomenon only holds true until we decide to observe or measure these particles. As soon as we do, the particle chooses a single state to exist in. It's as though the act of observation forces the particle to make a decision. This is what is famously known as the collapse of the wave function. The implications of this principle are profound. It suggests that reality, at its most fundamental level, is not set in stone, but rather exists in a state of flux until observed. This concept challenges our conventional understanding and intuition about the world around us. It's like the world is playing a game of hide and seek with us, revealing only a part of itself when we look. This is all quite perplexing, isn't it? But it's these strange principles that form the backbone of our current understanding of the quantum world. It's as if quantum theory is telling us that the world we see is just the tip of an iceberg, a small part of a much larger, more complex and indeed more mysterious reality that lies beneath. In the quantum realm, we are forced to accept that reality isn't as straightforward as we thought. The world, it seems, is far stranger and more interesting than our everyday experiences would have us believe. As we delve deeper into the quantum universe, it's clear that we are only just scratching the surface of understanding the true nature of existence. What if I told you that two particles can be intimately connected no matter how far apart they are? Picture this. You're in London and your best friend is in Sydney. You both have a pair of dice. When you roll yours, the outcome is instantly mirrored by your friend's dice, half a world away. Impossible, right? Well, this is the reality in the subatomic world, a phenomenon known as quantum entanglement. Quantum entanglement, an idea that even baffled the great Albert Einstein, refers to a very peculiar kind of connection that exists between particles. It's a connection so profound that the state of one particle is immediately reflected in its entangled pair, regardless of the distance between them. Whether they're a room apart or across the universe, the connection persists. Now you might be wondering, how does this work? Well, the truth is, we don't fully understand it. Quantum mechanics, with its eccentricities, often defies our everyday logic. But to give you an idea, imagine spinning a coin. Its state, whether heads or tails, is uncertain until you observe it. In the quantum world, it's as if the coin is spinning in both states at once until observed. Now, if this coin was entangled with another, the moment you observe one, the state of the other is instantly determined, no matter how far away it is. Intriguing, isn't it? This spooky action at a distance, as Einstein once called it, challenges our conventional notions of space and time. It suggests that at a fundamental level, the universe might be deeply interconnected in ways we're just beginning to grasp. It's as if there's a hidden layer to reality, a quantum realm, where the rules of classical physics are tossed out the window. Quantum mechanics, with its oddities and paradoxes, compels us to rethink our understanding of reality and our place in it. It tells us that the world is not as straightforward as it appears, and that our existence might be entwined with variables and phenomena far beyond our immediate perception. Quantum mechanics has indeed turned our understanding of the universe on its head. We've journeyed through a world of infinite possibilities, where particles don't simply exist in one state or location, but in an eerie superposition of states. We've grappled with the uncertainty principle, which boldly declares that we can't know both the position and momentum of a particle simultaneously. We've also delved into the peculiar phenomenon of quantum entanglement, where particles once intertwined maintain a spooky connection regardless of the distance between them. These mind-boggling quantum phenomena challenge our conventional understanding of reality, suggesting that at its core, the universe is far more mysterious and unpredictable than we could have ever imagined. So the next time you ponder about your existence, remember, in the quantum world, things are not as they seem, and in this world of infinite possibilities, you're not just a mere observer, you're a participant in the grand dance of the cosmos.